Hello, Math 100 students. This is your instructor, Mrs. Thomas, and today we are doing section 5.1, which comes out of chapter 5. The section that we're going to do today is called Factoring Polynomials and Solving Equations by Factoring. I am using your ebook, which is online. This first section is called Factoring Out the Greatest Common Factor, Factor by Grouping. We will identify the greatest common factor of two or more monomials. We will factor a polynomial containing a greatest common factor. We will also factor a polynomial containing a negative greatest common factor. We will also factor a polynomial containing a binomial greatest common factor. And lastly, we will factor a four-term polynomial using grouping. Okay, so our vocabulary for this week will be fundamental theory of arithmetic, GCF, which is called greatest common factor, and factor by grouping. First, let's identify the greatest common factor of two or more monomials. Okay, so let me write down a few examples for you. Directly from your text. And we're going to do the fundamental theory of arithmetic, which states that there is exactly one prime factorization for any natural number greater than 0. So, for example, if I wanted you to find the greatest common factor, which I will indicate is the GCF, of 42, 60, and 90. Okay, let's first start with what we used to refer to as the factor tree. So let's set this up. 42, 60, and 90. Get my branches here. Let's start with 42. Two numbers that when I multiply them together gives me 42. And I'm thinking about my timetable, so I'm thinking about my factors. 7 times 6. Okay, it's one of those factors. Now, 7 is called a prime number because the only thing that can be multiplied with it is 1 in itself. But I can break 6 down a little bit more to 2 times 3. Okay, so I always circle the ends of my prime numbers. Okay, so this is written with dots, 2 times 3 times 7. And I will do the same for 60 and 90. Two numbers factors that I think about when I'm thinking about 60. A plethora comes to mind, 12 and 5, 10 and 6. So let's try 10 times 6. Okay, here it can be broken down a little bit more. With 10, I'm thinking 2 times 5, that yields prime numbers. And we've just done 6, which is 2 times 3. Okay. So let me separate this so you won't be confused. I want you to be crystal clear. So here, this is 2 times 2 times 3 times 5. And I just like to put my numbers in order from least to greatest. Okay, I have 2 2s, 1 3, and 1 5. Now let's go to 90. I'm thinking about 10 times 9. Let me I can break that 10 and the 9 down a little bit more. So when I think of 10, I'm thinking of 2 times 5. And when I think about 9, I'm thinking about 3 times 3. And I'm hoping you are thinking the same as well. So here, if I'm writing my factors out, I have 2, 3, and 2, and another 3. Okay, so let me put this in order, y'all. 2 3s. And a 5, okay? Y'all, that just looks better. But if you wrote it this way, it's perfectly fine. All right, now, let's look for things they have in common. So I'm just looking here. I'm looking at all 3. I'm looking at what they have in common. Okay, 2, 2, and 2. Okay, any more factors? Wait, I see a 3. Okay, all 3 of them have a 3. Do you see anything else? They all have to share. So if I say, oh, what about 7? I don't see a 7 here or a 7 here. So no, they don't have that in common. What about a 2? Well, I see a 2 here, but I don't see a 2 over here. That means they don't have it in common. Okay, well, I got 5. Well, I see a 5 here, but I don't see a 5. You can't use it unless they all 3 have it. Okay, so the only thing that they both have is they all have a 2 and they all have a 3. So the greatest common factor is 6. Okay, the greatest common factor is 6. Okay. I knew that you would understand it. Let's try distributive property. Now that you understand what greatest common factor is, when I ask you the greatest common factor of a term, you'll understand it. Okay. So now let's do factoring a polynomial containing an actual greatest common factor. Okay. So let me give you an example. You know I love examples. Okay. Example 1 in your ebook. 3x squared times 2x minus 3y. Ms. Thomas, what should I do? We are going to use the distributive property, meaning I'm going to multiply 3x squared times 2x, and then I'm going to multiply 3x squared times negative 3y. So I'm just breaking it down step by step so you know exactly what I am multiplying. 3 times 2 is 6. And I have x squared here, and I have 1 here. So total, I have 3x cubed. X squared times x is x cubed. Okay, 3 times a negative 3. A positive times a negative is a negative. 3 times 3 is 9. I have x squared, but I don't have anything to add to it because these are unlike terms. And I have a y. So the only thing you can do is bring it over, straight over. It's nothing you can really do with it. Okay? So this will be 6x cubed minus 9x squared y. And that is your answer. So we're just trying to make sure you are able to multiply. Okay, let's try another one. Okay. Now I want to identify a term. I want you to think about the prime factorization of that term, what they all have in common. We're going to list each common factor to the least number of times it appears in any one term. And then we're going to multiply the factors found in the list, okay, to obtain the greatest common factor. So when I say that, let me give you an example. Okay. Factor 12y squared plus 20y. Okay. Well, Thomas, I don't even know where to start. Let's start with the greatest common factor. Okay, so I want you to visualize, or if you need to write it down, that's fine as well. Okay, let's figure out what they share. What do they have in common? Okay, I'm thinking about 12, 4 times 3, or you could have tried 6 times 2. It's wonderful as well. And I bring down my 2 times 2. Okay. So I always circle my prime numbers, and I just like to write everything down so I can have a visual. And of course, if you have y squared, that means y times y, just like we discussed in class. All right, and we're doing 20y. I'm just kind of looking and comparing. I'm thinking about 5 times 4. I can break down the 4 to 2 times 2. And let me separate this so you'll be able to see it crystal clear. So here I have 2 2s, and I have 1 5. And I have a y, okay? So now, help me figure out what they both share. I see a 2, I see a 2. I see another 2, I see another 2. I see a y and I see a y. Okay, so I only have to write it one time though. So what they have in common is 2 times 2, 2 times 2, and y. So how you write that is, they both share 2 times 2, so that's 4. And they only both share 1 y. They both share or have in common. So that's what I'm going to factor out. Okay, and open up a parentheses. My greatest common factor is 4y. Okay, now that you have your greatest common factor, I want you to factor that out and open up a parentheses. Now help me fill in the blank. For instance, I want my 12 as far as in my timetables. I have 4. 4 times what is 12? 3. Good. I need y to the second power. So I mean I need 2 y's. Right now I only have 1. I need 1 more to make it complete. Okay? A positive times a positive is a positive. So I can bring down my plus sign. Next, I need 20. So I'm thinking of my timetables. What to give me 20? I have 4, so I got to think about my 4 timetables. 4 times what is 20, which is 5. Well, I need only 1 y. I have 1 y already on the outside. So this is your factored answer. That's it. That's it. Okay? Not too bad at all. I think that you would have got this anyway. Now, we're still factoring. We're going to continue to factor. We haven't stopped. We're going to continue to factor. We will continue. Okay? Next, if I want you to factor, if you ever see this, okay, let's try another example. Okay? If I wanted you to factor a -1, okay, out of -a cubed plus 2a squared minus 4. Now, we've talked about this already, what factoring negative numbers mean. It means changing the signs. That's it. Okay, changing the signs. Well, Ms. Thomas, what do you mean by changing the signs? It's like having this -1a, -1 on the outside, -a cubed, plus 2a squared minus 4. And you are multiplying step by step. You're multiplying -1 times -1a. You know, this is a understood 1. We've already talked about that. A negative times a negative is a positive. So you bring down your a to the third power. When you need to put a 1 in front, you may certainly do so. A -1 times a +2 is a -2, and you bring down your a to the second power. A -1 times a -4, a negative times a negative is a positive. 1 times 4 is 4. Well, Ms. Thomas, the only thing you did was change the signs. Exactly. From a negative to a positive. Positive, negative. Negative, positive. The only thing you had to do was change the signs. So don't second guess yourself. You know exactly what you're doing. So just focus, just concentrate, and that way you will be successful. Okay, let's try with the actual problem. All right, if I ask you to factor -18a squared b plus 6ab squared minus 12a squared b squared. Okay, don't be afraid of it. Don't be afraid. It is just fine. Okay, so first and foremost, we can either do factor out a -1, let that come out at the very beginning, because we oftentimes like to deal with positives. Okay, I'm just writing everything out step by step. Okay, put that in the parentheses for me. Okay, let's change all of the signs. We're going to factor out a -1, meaning I'm going to stick that -1 out front. Okay, so then that would give me 18a squared b, changing signs, a negative times a positive is a negative, 6ab squared, and a negative times a negative is a positive. Okay, so the only thing you did was really you factored out a -1 and then you left the rest positive. Next, I need you to help me with a factor tree. Give me the greatest common factor. So if you don't know where to start, always start with the factor tree. Tell me what they have in common, and that's how you know what you should be factoring out, by what they have in common. Okay, so let's look at your timetables, 18, 6, and 12. Okay, let's just look at your timetables. Okay, 18 is 6 times 3. That will give me 18. If I break down 6 a little bit more, I have 2 times 3. Okay, so I have a 2. I have 2 3s. I have 2 A's and a B. And I just like to break everything down so I can get a visual of everything that I'm doing. Okay, a complete visual of what you're doing. Okay, help me break down 6AB squared. Okay, well, I know, of course, 2 times 3, that's going to give me, if you need to put a negative anywhere, you can put it in front of the 2 or the 3. But 2 times 3 is 6. So I have a negative, I have 2, I have 3. And if I break down my A's and my B's, I have 1 A. Just bring that down, and B to the second power, break that down. Okay, slowly. Okay, let's do 12. 6 times 2, that gives me 12. Let me break down this 62 times 3. Okay. And then I have 2 2s and 1 3. And I'm just writing down what I have left over. I have 2 A's and I have 2 B's. Okay. I'm just getting a visual of what do I have left over. Okay. All right. Let me start circling what they have in common. Okay. All of them have 2's. Okay. It looks like all of them have at least 1 3. Okay. We're just looking at what they have in common. All right. Now let me start looking at my variables. I see A, and A. Very good. All right. Do I see another A? No, I don't. This one does not have another A. Okay. Let's go to the variable B. B, and B. Okay. That's the only thing they have in common. All right. So they have a 2, a 3, a A, and a B that all 3 of them all share. Okay. You only have to write it one time. You don't have to say 2 times, 2 times. No. Don't do that. Okay. Just bring down what they have, what they all have. All right. So this is 2 times 3 is 6. And 1 A and 1 B. All right, so I brought out the -1 because it allowed me to change the signs. All right, so now I got -6AB. Okay, let me go back up to the original problem and help me fill in the blank. Help me fill in the blank. Okay, so here I need 18. Okay, I need 18. Okay, so how can I get, all right, I already have a negative, so I'm good on that. I need 18, so 6 times 3 is 18. I need 2 A's. How many you have? 1. I need 1 more to make it complete. I need 1 B. I have 1, so I'm finished with that. Let's move on. Okay, bring down my plus sign. Okay, or am I bringing down my negative sign? Which one am I bringing down? Okay, I want you to think about that. Because I need a positive. I need a positive here. I got to go back to the original. What I started out with. I need positive. Y'all, I think we should have changed it to a negative. That's what I think. I think we should change it to a negative. Is a negative times a negative a positive? All right, good. All right, I was just checking to make sure you was on your toes. Okay, I need 6. I have 6. I need 1 A. I have 1 A. I need 2 B's. I only have 1, so I just don't think I can put right there. It's B. Okay, all right, and then I need a negative here. Okay, so if I need a negative, then how can I make that work? Okay, does that mean that this has to be a positive? Huh? You know exactly what does that mean? Okay, so I'm noticing that I have positive, negative, positive. Okay, that's understandable. Okay, I'm going with the flow. Positive, negative, positive. Okay. I need 12. I have 6 so far. So 6 times 2, that would give me 12. Okay. So I need 2 A's. I only have 1, so I need 1 more. I need 2 B's. Sorry for that typo. I need 2 B's here. I only have 1. Okay. So this is my answer. Okay. And I'm sure you all probably got the answer before I got the answer. But that's okay. That's even better. That means we're working together toward a common goal. Okay. Very good. Let me start on part 2.